Okay, so we're back for video 2 of this lesson. And this first example I'm going to show you, example 3, talks about how to find measures of angles when you have a diagram and being able to read that and understand how to set up this equation. So this basketball pole forms a pair of supplementary angles. We can see from the diagram that these angles add to equal 180 degrees. We don't even really need the supplementary part, but it's good to just reinforce that vocab. So I want to find the measure of both angles. Before I find the measure of both angles, I'm going to want to find the measure or the value of x, all right? So knowing that these two angles add to equal 180, I can set up this equation. The sum of these two angles is 180 degrees. So I'm just adding together these two measures, setting that equal to 180. That's the equation I can set up. So then I move on to combining some like terms. 3x and 4x are like terms. 7x. 8 and negative 3 are like terms. That is 5. And then I just go about solving this. Subtract 5 from both sides. This is 175. Divide both sides by 7. That's going to end up being 25. X is 25. But that's not the end of this problem. I asked to find measures of angles. So the measure of BCA, what that's going to take is me substituting in 25 for x in the measure of BCA. So that's 3 times 25 plus 8. So the measure of angle BCA would end up being 3 times 25 is 75. 75 plus 8 is 83. So the measure of that angle is 83. And there's two different ways you could find the measure of AC or DCA. You could go ahead, substitute in 25 to 4x minus 3, and that's fine. Or to find DCA, a little bit of a shortcut, you could just take 180 minus 83 to find that other angle. So it's up to you. Either way, substituting in 25 times 4 is 100. 100 minus 3 is 97. On the flip side, you could do 180 minus 83, and it's still 97 degrees. But make sure that you're giving me degrees as an answer for this, because that is what I'm asking for. I'm asking for the measure of an angle, which would always be in degrees. Okay? So, got it? I'm just switching around the numbers, giving you a different equation to solve. So I'm going to give you a chance to pause the video, work through it, and then see how I explain through it to see, if you're understanding how to solve these. This would be a good chance to ask for some help maybe, or to flag me down. So pause the video, work through it, and then check your answer afterwards. Okay, so here we have the same situation as above. Same type of equation, same idea with solving this. So I set the two expressions equal to each other, solve for my variable, and then use that variable to substitute in, and then figure out what my values for, or what my measurements for BCA and DCA were. So those measurements turned out to be 81 degrees and 99 degrees. And it should make sense at the end when you check them out, you understand that they add to equal 180 degrees. So moving ahead to example 4, I'm going to talk about two new kind of relationships here. Linear pairs and vertical angles, okay? So I'm going to literally write out linear pairs. So in this diagram, we're going to look for linear pairs. And all you need to know about linear pairs is that linear pairs are pairs of angles that create a line. So these angles have to be adjacent. They have to be supplementary. So one set of angles that's a linear pair would be angles 1 and 2. Those are a linear pair. They create a line and they're adjacent, right? There's one more linear pair. Angle 2 and angle 3 are considered linear pairs because those are angles right here that form a line that are supplementary and adjacent. So supplementary and adjacent means that two angles would be linear pairs. Now vertical angles. Vertical angles have some different relationships, but this is a pair of angles. And the best explanation I can have for vertical angles is angles that are formed by two intersecting lines. So there's only one pair of vertical angles in this diagram. So we look at these two intersecting lines. I would say angles 1 and 3 are considered vertical angles. Those are angles formed by two intersecting lines. Now the reason angle 2 isn't vertical with angle 4 or 5, why those aren't considered vertical, is because those angles are formed by more than two intersecting lines. There's a ray coming in there. So we think about vertical angles, they're formed by two intersecting lines. So only angles 1 and 3 are vertical angles. On a side note, vertical angles are congruent. Angle 1 and angle 3 would be congruent, but we get into that a little bit later. All right? So in the got it, again, pause, check it out, see if you can answer this best of your ability, and then I'll explain. Okay, so for this example, I'm sorry I kind of threw a curveball at you here, but linear pairs in this diagram, there really are none. There are sets of 3 angles that form a line, like 1, 2, and 3 form a line, but that wouldn't be considered a pair. So there's no set of 2 angles here that are supplementary and adjacent in this diagram. So there aren't any linear pairs. This example is more to show you examples of vertical angles. So when I go over this, I'm just going to kind of show the lines that are intersecting. So with angles 1 and 4, those angles are formed by, wrong set of lines. Those angles are formed by two intersecting lines. This line and this line form angles 1 and 4. They incidentally also form angles 3 and 6. Okay, so that's why those are vertical angles. Angles that are opposite from each other when they're formed by two intersecting lines. For angles 2 and 5, they are formed by these two angles that make this x. So 2 and 5 are considered vertical. Okay, so moving ahead, last example. We look at this example. It says two angles form a linear pair. The measure of one angle is 4 times the measure of the other. So finding the measure of each angle. So some information that we know that one angle is 4 times the measure of the other, and they're a linear pair. So meaning when I add those two angles together, their measures should equal 180. So this diagram just gives you a chance to write out kind of an expression. So if one angle is x degrees, the other angle being 4 times that, the way I would represent that other angle is that other angle would be 4x degrees. And the degree symbol is just to show that we're finding a measure of an angle. So our definition of linear pair means this angle plus the other one that formed that linear pair add to equal 180 degrees. Linear pair, you think supplementary. So that'd be x plus 4x equals 180. To solve this equation, I combine like terms. 5x equals 180. X equals 36 degrees, if I'm not mistaken. Okay, so if x is 36 degrees, 4 times x, I'm going to grab my calculator real quick here. 4 times x, 4 times 36, sorry, is 144. And I probably could have done that using mental math, but wanted to make sure. So our two angles are 36 and 144. And you can test this by adding them together. Turns out they do add to equal 180. And if I take 36 times 4, it equals 144. So that's how we can tell. That's how we can set up an equation based off of this information, okay? So when we have that idea of linear pair, that's how we describe it. So it's a good chance for you to try the got it. It's the same problem, just with different numbers. So pause the video, take a second, and then I'll show you my solution. Okay, so for this example, I said I would maybe want to put a diagram out for this just to show, but these are a linear pair. The measure of one angle is 3 times the other. So if one angle measures x, the other angle's measures 3 times x. So I could say that those two angles add to equal 180 degrees. That's why I set up this equation. Combine like terms, divide by that 4, I get 45. 3 times that is 135. So my angles are 45 degrees and 135 degrees. So now you guys should be ready for the practice. Make sure that you're working through it and checking your answers and asking for help as you go along.